Here in this video, I will be explaining about centripetal acceleration. So centripetal acceleration arises due to the change in direction. I will explain it. You know that acceleration is equal to final velocity minus initial velocity divided by time. Now, centripetal acceleration has been defined for an object that is revolving in circular path with a constant speed, that is nothing but uniform circular motion. Whenever that is revolving with constant speed is nothing but covering equal interval or equal distance in equal interval of time. For example, at 5 meters per second. So though the speed is same, you know the velocity is a vector that is having direction as well as magnitude. So magnitude, see, whenever we are saying that velocity is 5 meters per second and revolving in a circular path, it is having a direction. At any moment, to get the direction, just draw a tangent in the direction of motion. So if it is revolving in anti-clockwise direction, here 5 meters per second will be in this direction, that is along the tangent, and directed along the direction of motion. Here it will be in this direction. So from the equation for acceleration, we know that change in velocity divided by time will be giving the acceleration. But here the magnitude is not changing, but velocity is a vector. So either change in magnitude can give the acceleration, or change in direction also can give rise to an acceleration. Here, see, if at all, if 5 meters per second become 10 meters per second, you will simply understand there is an acceleration because it has speeded up, it has increased the velocity. But here it is the same velocity, same speed, 5 meters per second and 5 meters per second. But the thing is, direction has changed. This is a vector. So this is basically a vector subtraction. To get and along with this, acceleration is nothing but the direction of the acceleration will be directed towards v minus u, or the vector v minus the vector u. Now this is vector u, so I'll just take vector u. This is vector u, and this is u initial velocity, this is final velocity. Vector v I'll take. So I can just simply copy from there and paste here. Only the thing is, I have to maintain the same dimension or same length and same direction. Here same length and same direction. So this is vector v final velocity, this is vector u initial velocity. Now, but we need vector v minus of vector u, or I can say vector v plus minus of vector u. Now how will you get the minus of vector u? This is plus vector u. To get minus vector u, then just reverse it, this is minus vector u. How to find the resultant? You have two vectors arranged in this way. You know parallelogram law of vector addition. If vector a and vector b are arranged in this way, then complete the parallelogram. This will be your resultant, vector a plus vector b. Now here you have vector v and minus vector u. To find the resultant of these two, complete the parallelogram, and this is the parallelogram. Then this will be the vector v plus minus of vector u is nothing but vector v minus vector u. Now this is vector v minus vector u, and we know that acceleration will be along vector v minus u. We'll just draw the radius of this circle. So radius will be basically perpendicular to this direction. To find the acceleration at this moment, what you have to do, you have to just copy vector v minus u here and paste it. Now this won't be, see, this will only be the direction. To get the magnitude, you have to divide it with time, but the direction will be same. So vector v minus u will be directed in this direction from here to here. So at here that will be like this. What you can infer from this? The acceleration will be directed, or the centripetal acceleration will be directed towards the center of the circle on which it is taking the revolution. Now how will we get the magnitude? So to get the magnitude, basically you have to substitute in this equation and get the value for that. If these points are very close by, I can approximate this distance. What is this? This is the arc length. And what is this? This is a chord. So this is a straight line and this is a chord, a path of a circle, a piece of a circle. This is a chord and this is curved length and this is a chord. If these 2 points are very close, then I can approximate this length and this length are equal. As it is moving with a constant speed, so you have calculated from here till here. So it is moving with a constant speed. So how will you get this distance? Speed into time will be giving you this distance, because it's covering 5 meters in every second. So after 3 seconds, first second 5 meters, again 5 meters, again 5 meters, total 15 meters. Similarly, speed into time will be giving you the total length in between these 2 points A, B. So this is nothing but, this length is nothing but speed, or I can say magnitude of velocity into time. This is radius and this is again radius. We know if this angle is theta, this is V minus U, right? I'll just give you a big picture of this. We have done parallelogram law of vector addition. Now we will do triangular law of vector addition. That is nothing but, see, for that you have to take it in the same order. Now this is in opposite order. Tail coincide with tail. Head coincide with tail is nothing but taking in the same order. So this is minus U. I'll shift minus U here with same length and same direction. Now this is vector V and this is vector minus U here, and this will be same here. I'll tell you why I have done this. Vector minus U. This is vector V and vector minus U. You know this length and this length are equal. Why? Because length represents the magnitude of final velocity and initial velocity. That's same in this case. Now if this angle is theta, now this vector makes the same angle with this vector. I'll repeat it. This angle is theta. Now you know that this makes 90 degree. The velocity makes 90 degree with radius vector. And again final velocity makes 90 degree with the radius vector. Now these two radius are making angle theta in between. You just take this vector, initial vector here, and place it here. Then that angle also will be theta. Just take it from here, okay, then place it here. You will be getting a same structure like this, and this two angle will be theta. Just go through the angular functions and you will be getting the answer. So this will be theta. Now we know that this is radius and this is radius. This is an isosceles triangle. If this angle is theta, then this will be 180 minus theta. Together, these two angles, the sum of these two angles will be 180 minus theta, because this is theta. Or total angular sum should be 180 minus the total angle this plus this should be 180. So these two has to contribute 180 minus theta, because this has already taken theta from it. Now, as it is isosceles triangle, these two angles will be same, 180 minus theta divided by 2 equally. Here in this case, same, this magnitude and this magnitude is same. Now if you are completing this triangle, then these together should be counting for 180 minus theta. As this is isosceles triangle, this should be 180 minus theta by 2, this should be 180 minus theta by 2. we can understand from this relation that this is a similar triangle with both of these two are similar triangle. If both of these two are similar triangle, we know the relation that connect the relation for similar triangles. So take the same angles theta and opposite of this v into t divided by this is the same angle that represent this angle, then this will be, here in this case we know that v minus u, because vector addition of these two from triangular law of vector addition. But how I can say that this is v minus u? Tail, head, tail, head. I am closing it, then I am making it, taking it in opposite order. Tail coincide with tail, head coincide with head. So this will be vector v minus u. So divide by vector v minus u is equal to, then take any of this angle. This is 180 minus theta and this is also 180 minus theta by 2. Both of them are 180 minus theta by 2. This is also 180 minus theta by 2. So opposite of this angle is nothing but r from the big triangle. Then from here that will be v. I am taking only magnitude. We know that v minus u by t is centripetal acceleration. So I will take v minus u that side and t this side. So v minus u by t, v into v square divided by r. This is centripetal acceleration. V minus u divided by t, that is centripetal acceleration, is equal to v square by r. Now how will we get centripetal force? We know that force is equal to mass into acceleration. So centripetal force is nothing but mass into centripetal acceleration, that is m into, what is v minus u by t? That is v square by r. Thank you.